Welcome to the Spintangle. We are here with a new problem from MIT entrance examination that is related to the topic called angular momentum from quantum mechanics. Let's read the problem first. A certain state psi is an eigenstate of L square and Lz. Okay. There are two angular momentum operators, one is L square and another is Lz. Psi is the eigenstate of L square and Lz also. Okay. Now read the question first carefully and then apply whatever you want. L square psi is equals to L into L plus 1 h cut square. What is L into L plus 1 h cut square? This one is the eigenvalue of the operator L square. L into L plus 1 h cut square, and then we got back the wave function. And then when Lz is operating on psi, we get mh cut as the eigenvalue, mh cut, and the wave function as it is. Okay. For this state, calculate Lx and Lx square operator, and these are the expectation values of Lx and Lx square. Okay. We know the conventional two operators. These two operators are L square and Lz. Lx and Ly are not too much important. I don't call it not too much important. It is less important than Lz and L square, because Lz is the conventional direction for measuring the angular momentum. Okay. Then we know one thing, that first of all, what is expectation value of Lx operator? This is written as psi Lx psi. This is the angular as operator. Please give a cap on the Lx operator. Okay, fine. We know Ly Lz commutation relation gives I h cut Lx. Therefore, Lx equals to 1 by I h cut commutation relation of Ly and Lz. We can write it easily. Then put it in this form. Okay, psi. Put the commutation relation. What is this? In the place of Lx, 1 by I h cut Ly Lz. Ly Lz commutator, and then sandwich in between two psi's. Okay. Just wait. This gives us the 1 by take the 1 by I h cut. This is the scalar factor. We can take it out from the bracket. Psi commutator Ly Lz psi. Okay. And this can be expanded as follows. Psi, we know commutation relation gives us Ly Lz minus Lz Ly. Okay, and then psi. Okay. Now, what we can do here? We can do one thing, that 1 by I h cut psi Ly Lz and psi minus psi Lz Ly and psi. Okay, is it okay? I think you are familiar with the basic commutation properties of the angular momentum operators. Give a third bracket here, because 1 by IH cut is on these two factors. Okay, then what we can do here we can write it as follows, that psi operator psi, this is the let me change the color. This thing gives, this value is what is the value? Lz psi is equals to mh cut psi. This is state formulation, and taking its Bragg formulation, what we can write? Psi Lz is equals to mh cut Bragg psi. Okay, is it okay? Then we can write psi Ly, then this is, there will be mh cut psi. We can take the mh cut out of the box. Mh cut psi Ly psi minus, we can do here also the same thing, that this is the Bragg formulation. From this formula we can write it as follows, that mh cut psi Ly psi. Okay, you can see one thing, that these two things are same inside the bracket. These two things are same. Okay, therefore we can subtract one from another and we can get a result as 0. Okay, this means the expectation value of the operator Lx becomes 0. This one is the first part of the question. Going to the second part. Okay, second part. Let me check what was the second part. The second part was, what is the value of Lx square operator? Okay, we know one thing, that angular momentum L square equals to Lx square plus Ly square plus Lz square. It is it can resemble with the fact that L dot L vector, what it becomes, Lx square plus Ly square plus Lz square. In the classical mechanics we have taught this thing, that L square operator given as Lx square operator, Ly square operator and Lz square operator. From this we can write that Lx square operator as, let me write it here, that Lx square equals to L square minus Ly square minus Lz square. Okay, then from the property of symmetry, space symmetry, you can write it space symmetry. From the property of space symmetry, what we can write is Lx square operator is equals to Ly square operator is equals to Lz square operator. These are the expectation values of Lx square operator, Ly square operator and Lz square. Not directly Lx square, Ly square, Lz square. I am not writing this. I am writing the expectation value of Lx square operator, Ly square operator and Lz square operator. Okay, then from this we can write that Lx square is equals to Ly square is equals to half into Lx square plus Ly square. We can write it because Lx square operator, these are operators. Okay, these are operators. Let me write it clearly. Lx square operator plus Ly square operator. Okay, these are the expectation values. We can write easily because we know if A equals to B equals to C, then we can write A equals to B equals to half into A plus B because they are same, and we can take their average. This is one kind of average we have learned from in earlier classes. Okay. Then what we can draw from this, that Lx square operator is equals to Ly square operator is equals to half into, what is this? Lx square plus y square. This, let me change the ink. Okay. Lx square operator plus Ly square operator. In this place we can write from this formula, from the above mentioned formula, we can write that Lx square operator is here we can write is L square operator minus Lz square operator. Is it fine? Here we can subtract. Okay. Then finally we have got one thing that expectation value of Lx square operator becomes half into L square operator expectation value minus expectation value of Lz square operator. Is it okay? Please comment on the comment box if you have any problem, any doubt. I will surely clear it. Okay. Then what will be this? Half into expectation value of L square operator is what? You know it, expectation value of L square operator is L into L plus 1 h cut square. What is the expectation value of Lz square? It is expectation value of Lz. We know it as m h cut. If it was Lz, then we can write it as m h cut. Lz square, then we can easily write it as m square h cut square. Then put m square h cut square. Take common m square h cut square, half into L plus 1 minus m square, out of the bracket take as h cut square. Okay, is it fine? This one is the first problem where we have calculated two values, that expectation value of Lx operator is 0 and expectation value of Lx square operator is not 0, is this value. Okay, this one is the expectation value of the Lx square operator. Is it fine? Okay, thank you.